Hello everyone. This video will be on the 3.10 section of the IBAA curriculum. Please pause the video for a second to look at the concepts, contents, and formulae for this section. One sentence that summarizes this section is, more identities means more cards we can choose from. This section is a direct follow-up to the 3.6 section where we learned about various trigonometric identities. As you're in the HL math now, there are some more identities we can play with. Let's look at the compound angle identities first. They're straightforward, all simple to use, and we use these the same way we would for the double angle identities. Speaking of the double angle identities, can you see how we can use the compound angle identities to come up with the double angle identities? That would be a fun exercise. And also, this leads nicely to the double angle identity for the tangent. Would you like to try it yourself? Before we do an example question, I want you to think for a moment about where these identities come from. It's like a train of thought. Which one would be the first one? How do you know this is true? These questions tie very closely to the TOK as well. I tell you that these are true, that both sides are equivalent, but how would you know it? As a math HL student, these are obvious questions you should have and perhaps be able to explain the answer. If you understand how to prove the identities, you will definitely have the necessary skills to use them as well. Now, let's try an example. Simplify tan 80 minus tan 20 over 1 plus tan 80 tan 20. Just by looking at this, you should realize, I don't know how to do this because 1080, that's such an awkward number, right? So that's why we look for the formula booklet and see if there are any identities that looks just like it. Do you see it? Well, yeah, this is a compound angle identity for tangent. And specifically, this is looking at the negative version of it because it's 1080 minus 10b, and then the bottom side it becomes 1 plus 1080 and 1020. Okay, so I can switch this into tangent. A would be 80 degrees. This is minus 20 degrees, which is the same as tangent of 60 degrees. Okay. I think we can obviously draw a quick triangle, a special triangle, where the angle is 60 degrees, and that would be 1 and square root 3 over 2, and then 1 over 2. Because we're interested in the tangent of it, opposite over adjacent, so square root 3 over 2 divided by 1 over 2. Let's look at another question now. Show that square root of 2 times cosine of theta plus pi over 4 is equal to cos theta minus sine theta. All right, this is kind of confusing, so let's just look at the formula booklet and see if we can find something that we can use. On the left-hand side, I saw that there was a compound angle, so perhaps I can use the compound angle identity for cosine. The cosine of a plus b is same as cos a cos b minus sine a sine b. So let's do that. I'm going to leave out square root of 2 on the outside. And then I'll say cosine a cosine b. So cos theta cos pi over 4 minus sine theta sine pi over 4 is equal to cos theta minus sine theta. Remember that when you're solving a show that question, you usually don't want to, go over the equal sign like we usually do when we're solving an equation. Anyways, I know that if I can draw a special triangle where the angle is pi over 4, the sides are the same as 1 square root 2 and 1 here. So I know that cosine pi over 2 would be adjacent over hypotenuse 1 over square root 2. It will be cos theta 1 over square root 2. The same thing for sine pi over 4. Sine pi over 4 is also 1 over square root 2. You can distribute square root 2 onto both terms. We get cos theta minus sine theta equals cos theta minus sine theta. And now we know that the left-hand side equals right-hand side, and we've shown that they're equivalent. If you would like to, you can search in the internet some additional trig identities that may or may not be helpful for your problem solving in IB exams. Be sure to question, however, how would you prove the identities? That is a key component for success in this section. I hope you enjoyed this video and try some questions in this section to really master the skills that we've learned. Anyways, I'll see you in the next video. Best wishes.